So, well, you almost told me that most of you were familiar with the technology. When we get to these sessions, we don't know if there's new people around observability or not, but pretty much everybody knows Fluent Bit, I think. So I will try to go a deep dive on observability. So not deep dive, but a quick overview, and then jump into internals of the project and where the project is going, and then have a good Q&A around architectures, data patterns, and everything that might help in your deployments. So my name is Eduardo Silva. I'm one of the creators of Fluent Bit. I'm now the founder of this company called Calyptia, which is the enterprise layer on top of this open source project, and a CNCF maintainer inside the Fluentd graduated project. So one of the things with observability is always the question is what's the state of my applications, right? And that's why this kind of tooling exists. Even if we think about individual servers, if we want to monitor an application, it's typically we go to journald, syslog, or try to see how the logs are behaving. And from the other angle, if we want to get some kind of signals around metrics, which are numerical, right? We try to go with top, PS, or netstat, or everything that gets processed through the prox file system. And this is ideal for single node environments. We know that nowadays we don't want to SSH into a machine to see how it's behaving, right? We want to extract information in a different way and maybe centralize this information. And that's very much because we are playing with distributed systems. Everybody now it's mostly deployed on containers or multiple VMs. And if one application gets replicated across your stack, right, it's really hard to SSH into each one of them. So that it is not longer necessary. So how do we solve this problem? And one of the options is like we have different tooling and services to ship logs and metrics from each single node. And one of the approaches from an architectural perspective is that we try to centralize all this information in one place so the user can perform the initial task, right, which is data analysis. Everybody does logging and metrics not because it's fun, but you have to in order to understand what is the state of your own applications. So, and when we talk about observability, we start talking now about different signals that exist, right? One of them is metrics. We have the first one has been logs for years, and people started doing metrics as logs. They used to start shipping certain metrics as logs in the past. Now we have native payload for metrics, and also we have other kind of signals like more advanced, which are traces, but that requires certain instrumentation inside the application, which are mostly created for a different purpose than logs, different purpose than metrics. But if you have an architecture where you have a microservice that depends on other microservices, you want to understand what is the workflow, what's the application behaving from the first request until the last one across different endpoints, and that traces is really important for. In observability, from a project perspective, in the CNCF stack and outside of it, there are many projects, right? You will find Prometheus for metrics, eBPF, where you can gather metrics directly from the kernel and get exposed to a user space. OpenTelemetry, that's trying to solve all logs, metrics, and traces from just one unique specification and implementation perspective. We have Jigger for tracing, Fluentd initially for logs, OpenMetrics, which is kind of a sub-project of Prometheus for metrics spec, and also Cortex. So when we get into the journey of observability, we always get this problematic of, okay, which tool should I start with, right? And actually, always the answer is what kind of problems you want to solve. But it's not that easy because we know that most of these tools run as agents of services, and once you deploy them, or maybe you get certain scale like, I don't know, 100,000, it's not that easy to start switching the agents, switching configurations, and connecting the dots between all your observability stack. Because at the end of the day, this is like the first mile, right? How do you get the data? How do you try to send the data to a different place? Because every user, even every customer, has a different kind of backend. Some of them prefer Splunk, some of them use OpenSearch or Prometheus, or standardized with Grafana and Prometheus, or any kind of other solution. And this session is mostly about Fluent Bit, and not just the project itself, but the role that is playing inside the CNCF and the cloud native environment. One of the visions for Fluent Bit initially started like a high performance version of Fluentd for embedded Linux. I'm talking about 5-6 years ago, but quickly evolved as a solution for containers because it was more performant, lightweight, and could perform 10 times more than Fluentd. Fluentd has certain restrictions, single thread, it's Ruby. It does the job, but a certain scale for nowadays demands of data management, the scale of data that we have, sometimes not enough. And the way that we see nowadays Fluent Bit in the last 2-3 years has been evolving, because if you go to an environment, it's not like you have one solution in place for everything. You either have Prometheus endpoints, right, where you expose a metrics, while in the other environment, maybe you are experimenting with OpenTelemetry. And then you are starting adding, I don't know, certain feature sets for each project, and you don't have something that is uniform in your stack. What is uniform is that most companies try to get open source vendor agnostic. Yeah, that's where we are now, right? But the next layer is like, are we trying to unify it just in a single protocol? It's hard to say. It didn't happen with logs, right? We're still dealing with syslog, which was created, I don't know, 30, 40 years ago. And the thing is that the way that we see Fluent Bit is like, it's becoming like a good, I don't want to call it like a proxy to connect the dots between different implementations. Fluent Bit started as a solution for logs, high performance, but 2 years ago we started implementing and extending the scope to metrics handling, but not to replace Prometheus, but integrate with Prometheus, managing and having its own native schema for metrics. And now we are doing the same for OpenTelemetry, right? So no matter what you have in your environment, you can play with syslog, with logs, or just do Prometheus to OpenTelemetry by having the same agent that you have now. So you don't need to deploy anything else, right? And one of the values of this open source agnostic approach is like, yeah, no vendor lock-in. You don't get tied to a specific framework, not get tied to a specific implementation. Fluentd and Fluent Bit has been around, well, Fluentd 10 years, 11 years, Fluent Bit for 6 or 7. And now, well, who's using Fluent Bit? We know most of cloud providers, if you deploy any kind of Kubernetes cluster on EKS or GKE, you will find that Fluent Bit is running in there. And we're seeing as maintainers that in the industry is trying to get rid of multiple agents in the environments, because when you have multiple agents for different needs, right, historically they were created for that, it's really hard to maintain. You get this problem or where you are upgrading your operating systems because of security reasons, end of life, and then the next problem is what about your applications, the dependency of the applications, and observability also has a dependency on that. Are your agents be able to be portable across different distributions? We have many users that run CentOS 6 still. Yeah, they are going to move to Rocky Linux or different stuff. Yeah, but that transition takes 1 to 2 years. So it's really important that the things that we're using is able to be used in different distributions, even the ones that are not supported anymore. Because it's a lie that if we say, yeah, everybody will migrate to the latest version in production. That don't happen quite easily. One of the highlights of Fluent Bit, well, it's a production grade in an enterprise, high performance. I already said about all of that. And the way that you can consume it, we have the upstream version, right? So you can get it for packages, you can get the container image. AWS has its own distribution called AWS for Fluent Bit. What is the difference? It's like they have their own specific Golang custom plugins in their images, so for their own Amazon needs, but it's the same upstream version, there's no changes. Actually, we work pretty much together. We have maintainers in AWS that works with Fluent Bit. At Calyptia, our company, we have our own Fluent Bit edition, where we call it LTS. That is a private edition, but long-term support, mostly for banking institutions that need to run 18 to 24 months of security updates, because they cannot follow upstream releases, right? We release a new Fluent Bit every 2 weeks, and sometimes things could get break. And a Google Ops agent is like a new agent in the market for Google needs in the cloud, right? Which bundles OpenTelemetry for metrics and bundles Fluent Bit for logs management. And pretty much the concept is pretty easy. We always try to standardize and get any kind of information from any type of source and be able to send the data to any type of destination that is new in the market or that the user needs. And nowadays we face more than 2 million pulls from Docker Hub every single day, which is insane number of deployments, and this is growing. And one of the problems is that when you get more adoption, you get more bugs and more enhancement requests, right? And developers don't grow exponentially. Actually, it's totally the opposite. So, but it's a good challenge, you know, more adoption, more problems, but also more fun. Now, getting into more specific terms about logs, metrics, and traces. Logs has been something that has been supported from the beginning. We deal with unstructured, structured messages, schemaless, but also we provide the option to process the data as soon as we get it into the pipeline. We can run filtering to enrich it with Kubernetes metadata, AWS metadata, or maybe if you want to bring your own business logic into the Fluent Bit pipeline, you can run a Lua script. And Lua allows you to modify the records or do any kind of enrichment, or maybe drop the data that you don't care about before sending the data out to a destination. In metrics, this started beginning of 2021. We defined a schema for metrics. When we send metrics, what is the difference than logs? It's a different type of payload, right? Because metrics are pretty specific. A logs is just a bunch of key value pairs. A metrics is defined. We have a type like a counter, gauge, right? And you can have histograms, but also they have dimensions like levels, right? So, and all of that has been implemented in Fluent Bit in a way that the data, our own data format, can be compatible with Open Metrics, which is a Prometheus format, and Open Telemetry. So any metric that we get from any kind of type like Prometheus or our own internal metrics, we can expose them in a different format that the user needs. And from an integration perspective, we have a Prometheus scraper. So if you have some applications running with Prometheus endpoints, you can use your same agent Fluent Bit to scrape the metrics and expose those metrics somewhere, wherever you want. We have a replication of the node exporter project by Prometheus inside Fluent Bit, so we can collect the same local metrics as this external project does, and we can do Prometheus exporter, or we can do Prometheus remote write. Prometheus remote write was never intended to be like a protocol to transfer metrics in a public way, but since most of vendors, even for example New Relic or Google Cloud, they allow to receive the data in Prometheus remote write. That's why we implemented this in Fluent Bit. So if you have the agent, yeah, you can connect to any kind of vendor that implement those protocols in their own endpoints. Open Telemetry is a new big thing, right? The industry is trying to standardize how to do, I would say, okay, not how to collect, how to receive the data in a unified format that most of vendors can take advantage of it. Meaning, like, if today I'm a user, I'm using company A, where I'm sending my data, right? I can switch to provider B without any disruption change, just changing the protocol, just changing the endpoint. So everybody who supports Open Telemetry, right? I can switch between vendors, and that gives the freedom to the user. Now, Open Telemetry as a specification is a framework, it's a project as a framework. It tries to implement all about logs, metrics, and traces. And the way that we approach this is like we implement the Open Telemetry protocol, OTLP, inside Fluent Bit. Nowadays, this is experimental. In the input side, meaning where we receive the data, we support metrics and traces right now. And in the output, we support log, metrics, and traces. This is all pretty new implementation for a few months ago. But we are already getting some contributions back. For example, LinkedIn is really interested in to get tracing support in the input side of Fluent Bit. Fluent Bit is deployed widely in LinkedIn in Kubernetes clusters, right? So they are instrumenting applications with Open Telemetry, but they don't want to switch agents. So they are extending and contributing back to Fluent Bit to be able to flow this new kind of information. And as part of the internals, this one not the intention of initial proposal for this presentation, but we know that the audience of Scale is very technical and like to go to deep dive on how things works. So I'm going to talk a bit of how this works internally. So Fluent Bit, as I said, was designed with performance in mind. right? And all the data that gets into Fluent Bit internally, when we manage it, we do some kind of binary serialization, right? Even if we get a JSON, that gets a binary representation inside Fluent Bit. And once you get the data, that data needs to be somewhere. And we use different kind of buffering mechanisms, either in memory or file system, which is a kind of hybrid mechanism. Because one of the problems that as an agent is that, yeah, you get the data, but it's not as easy as to get the data and send the data out. The problem is that when you want to send the data out, network fails. The endpoint is down. So what do you do on that when that happens, right? That's why we have buffering mechanisms. And what about if the agent crashes? Do you lose the data? No, if you enable file system buffering, because you have a backup of that, right? We don't have unlimited resources in a machine, right? But we try to provide the right layers so the agent can survive under different failure scenarios. A log workflow, you know, this is pretty simple. An application trigger a message, right? And that message could be an unstructured message. Unstructured could be any raw text message that we understand but necessary for the computer. It's just an array of bytes. And if we think, for example, an Apache log file, that becomes multiple lines in a file. But when we do logging, what we do is trying to centralize this in one central place, process the data, get into a central place of unit processing, and then be able to send this data to the destination where the user is going to consume this information for analysis. It could be anything. It could be Splunk, Amazon S3, OpenSearch, or Elastic. Right? The agent has a lot of work to do, right? One of the things is like be able to collect all these kind of events, provide mechanisms to parse the data, because you don't get a binary representation with a structure. You get raw data, right, as I said. Or sometimes, if you're running, for example, in AWS, you want to enrich your logs with the metadata for that host. What is the host name? Or maybe you want to append a label to those records. Because when you do an analysis, you want to query the data not by patterns, but by using labels or certain metadata. Manage buffering and be able to send the information to different destinations. We call this like the output destinations or backends. From a project perspective, we try to support most of them that are available in the market. And I think that between input, filters, and output, we have around 100 plugins available. Right? So, and it works like this: input, processing, output. It's not more complex than that from a usability perspective. And in the internal side, the input plugins or the input interface, what it cares about is I/O, disk, network, and internal metrics, while the engine internally cares about parsing, filtering, serialize the data, do buffering, routing meaning decide where this data is going to end up, and schedule how this data will go out. And if it fails, how I'm going to retry this data. So this is how do we prepare for different failure scenarios, but the user needs to define, yeah, this is my retry logic. If things goes wrong, this is how I'm planning to move forward. And in the output plugins, they have a different set of tasks that to do. Mostly it's around network setup, format the data. You remember that I said that we serialize the data in our own format? Yeah, output plugins need to care about take that binary data and format that data for the expected format of the destination. For example, Elasticsearch waits for a JSON, right? Splunk a JSON but has a fixed schema. So we do all this translation on the output plugin side, right? And that's the main job of Fluent Bit. Now, from a data serialization perspective, we use a specification that is called Message Pack. Message Pack was created by the Fluentd creator, right? And Message Pack was created before Fluentd. And the goal is that you can have all this kind of structure with key value pairs from different types in a very optimized sites. It's not compression, but it's just using binary representation that you save a bunch of bytes in general. As you can see, for example, in the latest one, imagine that if you have any kind of representation in JSON that has a null value, that is 4 bytes, right? You don't need 4 bytes. I don't know, I was thinking today when I was doing this, it's like, what would happen if JSON specified that instead of null, you just use 1n? Can you imagine multiply that for thousands of messages per second, how many bytes you can save? And that saves storage, that saves cost in the company. That's why sometimes people prefer some binary encoding than JSON when transfer the data. That this is, well, message pack, this is a comparison of how it works. And when we get the records inside Fluent Bit, we serialize them in message pack, and we put them in a concept of chunks. A chunk is a concept of multiple records. Binary, they're serialized, and they have a tag. A tag is like a label that is something representative for that information, because when you're going to do routing meaning I'm going to send this data to some place, we use the tag to decide where the data will go. Okay, and when the data gets in, by default we have some kind of pool of buffering in memory, so we start putting all these chunks in memory while they are being processed, right? At some point we are in, this is like a queue, we're putting them in memory, and at some point the other part of the engine start pulling them out and passing these chunks to the output plugins, who cares about shipping the data to the right place. And this is a fastest mechanism because it's just memory usage. The problem is that it's not persistent, and one of the biggest problems is that you don't have unlimited memory, right? What would happen if your destination is down and you keep ingesting data, right? It's going to consume all your memory, but before that the kernel will do something really good, which is kill the process, right? Because you cannot, it's not all you can eat, right? And one of the solutions for this problem is a hybrid buffering mechanism where we use memory and file system at the same time. What we do is to make the engine write these chunks to disk, but the good thing is that it's not like a normal I/O operation with read or write system calls. What we do is kind of manage all of this with memory mapped files, so we get a memory representation of the file where we write to memory, and the kernel makes sure to synchronize the changes to disk. This is kind of a strategy that database use mostly, but in general, if you enable file system buffering in Fluent Bit, what you're getting is memory mapped files, which is really performant and has less overhead than using normal system calls when using disk. For example, Fluentd uses normal read-write for the file system, and that adds a lot of latency, and of course it has some performance penalties. This mechanism is really fast. I would say, well, 99% of Fluent Bit production environments are using this kind of setup. Right? Fluent Bit 2.0, it's coming at the end of September, right? And there are many good things that are coming. I don't know if I told you, but at the beginning, Fluent Bit was just a single thread process, right? And the way that it used to work in order to scale is that it has a main event loop, and this event loop, when it's time to ship data to the destination, it just creates a coroutine, which is like a lightweight thread, and do a lot of suspend and resume operations on the output plugins. So everything thinks about Windows 3.1, where you have just one single CPU, but you can do multitask stuff, right? It's like the kernel behind the scenes, or even in Linux, right? It's hiding all this context of switching context in the code, but in Fluent Bit we took the same approach. After some time, the performance was great, but it was not like the companies needed. So we implemented threading in the output side. Now, when it's time to take the data, convert to JSON payloads, do all the networking, TLS handshake, all that involves, what we did was create all of that, deferred all that job in an output thread. And nowadays, if you're running Fluent Bit by default, most of the output plugins runs in a separate thread. Now, what is coming with Fluent Bit 2.0 is that we are implementing threaded input plugins, because the problem that we face in the output, now we're facing it in the input side. Most of users now are using Fluent Bit as an aggregation tool. We receive many connections, right? And in order to scale and be able to process all that data, we need to take advantage of CPUs, right? Pretty much every server will have more than, I don't know, 30, 40 CPU cores. So if we do it in separate threads, of course, we can offload the work to different destinations. Also, one of the requirements that we got some time ago is like we supported Golang output plugins for some time, but we got the same requirement for the input side. It's like from a user and developer experience, so how can I extend this pipeline? How can I add my own protocol or my own handlers? So right now we are shipping native Golang input plugins, so you can write your own Golang plugins. Those get compiled as a shared library, and you can just run Fluent Bit and tell it, hey, the shared library file is here, this is a Golang plugin, just run it, and it will be there to go. As I said, OpenTelemetry also is something that is going to be shipped officially. You can find the OpenTelemetry work right now in the 1.9 series, but yeah, we call it kind of experimental. We got some users, but we are making sure that this gets to 2.0 release. And another interesting feature is TAP. I don't know if you are familiar with the concept of TAP in observability. Imagine that you just set it up a configuration, the data is flowing, and at some point you said, hey, I would like to know what is the data that is flowing from this input plugin. How do you query that? Yeah, you can go to the database, but that goes through a different filters to the destination. But how you can get a snapshot of the data in real time, and that is TAP. So by TAP is a new HTTP endpoint that we will have in Fluent Bit. So you just issue a request, and Fluent Bit will create a window where from that minute or whatever you set it up, it's going to give you a copy of the data that is flowing through an input plugin. So you can say, oh, this type of data is flowing, right? And maybe when you find, because most of the problems that you find in configurations are not in the config, are when you store the data and then you try to do some troubleshooting and you find, oh, my data has the wrong format. Why? Something changed, because you don't control who's sending the data, right? Maybe the developer on the other side who's sending the data changes stuff or enables some dummy flag on the tool, and the structure of the data changes. So TAP is a solution that allows you to inspect all these issues and do some kind of real-time debugging of the data pipeline. And well, in observability, it's like a suggestion, always try to be fluent like water. So try OpenTelemetry, try Prometheus, but always making sure that things could go smooth. I think that Fluent offers a good example. So this is not about replacement tools. I think that the opposite in observability is be able to integrate with the others and the new projects that are coming in, right? And bless you. As I don't know, one of the features that I took in the I don't know if this is too small. Let me check. In the presentation was the ability of Fluent Bit to scrape a metric from Prometheus or the node exporter. So I would like to show you a simple configuration that mimics what is node exporter tool from Prometheus. So as you can see here, oh, it's too small. Can you say it, or it's too small? Too small. Better? No? Better? Okay. So pretty much in Fluent Bit you define a pipeline with inputs and outputs. This is a classic configuration. We also support YAML mode. So in the input we have a plugin called Node Exporter Metrics, which mimics Prometheus Node Exporter Metrics. What it does is pretty much gather all the metrics from the host where it's running, right? And export that in Prometheus, and you can use it on your normal Grafana dashboards. And what we're doing in this example is we are going to publish those metrics in a Prometheus exported endpoint inside Fluent Bit, right? So this runs like this. We got Fluent Bit running, and it's exposing the metrics on port 2021. So as you can see, for example, we can scrape this Prometheus endpoint like that, and we will get all the Prometheus information. So in the same format that Node Exporter does, but using Fluent Bit. Let me put some color on it. It's like prom color. There you go. So let me scroll up. So you can get the same metrics but by using Fluent Bit and talking the Prometheus protocol. Of course, you can do other stuff too. Maybe you don't want to do this kind of networking stuff. You can ship the metrics by using, I don't know, the same metrics if you want to spec them by using stdout. And you're going to start getting the metrics in the standard output format once they are collected. So we're going beyond logs. Metrics is something that is being heavily used right now, and well, the next big thing is traces, right, that we are shipping now. So yeah, I wanted to show you what is going on with the project and what is the next in the roadmap, but also open the discussion for questions that you might have. I'm sure some of you are Fluent Bit users, so please just raise your hand. And oh, I was instructed to pass this microphone.
I can try to say it, but you might want to speak to the recording.
Yeah.
I have a question about the Prometheus one. I didn't understand exactly which setup is it. So you are getting the data from the application and exposing them as Prometheus, or are you scraping the application in the example?
Okay. The question is, there's some confusion in how to explain the Prometheus configuration to understand, are we pulling, getting the data somewhere, or are we exposing it? Okay. I'm going to explain it this way. I'm just running the helper for Fluent Bit. So the input plugins for Fluent Bit aims to collect or receive information from some source, right? This plugin that we have here, which is the one that I use in the configuration, is not exporting metrics. What it does is a copy-paste of the Prometheus not exported project, but inside Fluent Bit. So Fluent Bit is the one that gathers all the metrics from proc file system, create the internal metrics payload, and get it ready to ship. We are not using the Prometheus tool. This is just purely Fluent Bit.
You are scraping and you are shipping.
Okay. Scraping, I would say I'm scraping locally from the file system, from the proc file system. We're not using not exported natively. And the way that I'm exposing this information is by using the Prometheus exported output plugin, what allows others to scrape my metrics. This is like the pull model, right? Others pull my information, but also we can do the push by using remote write.
So if the application is not exposing the metrics for scraping, you will do this already. You allow now to expose the metrics.
Yeah, we can expose any type of metric. We also can scrape metrics. For example, if you have one application, your own application, Golang Node.js, that has a Prometheus endpoint, right? We can use the Prometheus scrape plugin, where Fluent Bit will scrape your metrics and get in the pipeline, and from there you can do whatever you want.
What's the scrape rate? How often is it scraping?
Sorry, I didn't hear the question.
How often is it scraping?
How often? The interval by default, I think that is 2-3 seconds, but you can configure the interval. For scraping or not exported, each one has its own options. Let me check. No exporter metrics. Use H. Here's scrape interval 5 seconds. Yep.
So I was going to ask you also about the input external plugins. Do you have any plans for the other type of plugins, or is just input for now?
Okay, the question is if we have any other plans to integrate other type of input plugins?
External plugins.
External, like in different languages?
Golang.
Yeah, Golang is something that we're shipping now for September.
So that's for input, right? But what about filter, the other side?
Yeah, filter is an interesting question, because the thing is that in filter we support Lua scripting, and most of users are okay with that. There are some users that are saying, I'm going to implement my Golang input plugin but I don't need a filter because I'm going to implement my filtering logic inside my own plugin. So the demand for Golang filters is pretty low. Yeah, actually, yeah, running Golang code is really heavy. So, meaning like the context switch between C and Go is really expensive. Yeah, that's why we're implementing threaded input plugins, so your Golang input plugins will run in a separate thread and will not affect the main pipeline performance.
That was my second question also. Now that you're going to have input and output using external tools, Golang, have you benchmarked on what's the impact for Fluent Bit of using this context switch? Let's say that I want to use my own input and also my own external output. I mean, my own input and my own output.
Yeah.
Have you benchmarked if I abuse of Fluent Bit of using external switch?
I would say that the impact, there's a performance impact for sure, but I would like to refer you to a document that AWS wrote about that, because initially they had their own output plugins written in Go, and after some conversation and some beers, we convinced them to write it in C. And they did the conversion to C, and the performance went up, right? So, but after that, there's not much research on performance on that area. Actually, remember that Golang input plugins is pretty new, so we're just going to start getting all this feedback. So we're just making sure to run this in a separate thread, right? So pretty much your code will be running pinned to a different CPU, and will not affect the performance of the main pipeline. The problem, not the problem, but the downside if you use a Golang input plugin or a Golang output plugin is that you're using your own APIs, your own external packages, right? That's one of the problems that, well, most of languages have. That's why in Fluent Bit we prefer to implement almost everything from scratch by using our own API, because we know how to optimize memory, how to optimize I/O. But when you're running Golang, you are by your own. Yeah, so it's like, yeah, but you can write plugins faster, you can prototype faster, and yeah, well, AWS, they have many customers running the Golang plugins while others running the C plugins. Yeah. Sure, please. Yeah, we have time, so.
And you mentioned a little bit about the retry, and also you talk about the pushback on memory when you were speaking about the chunks and how I read to this and all that. So when does Fluent Bit give when Fluent Bit stops retrying?
Stop retrying. Yeah. When sending the data out, when flashing. Yeah, by default we have a default policy of 3 retries, 2 or 3 by default. You can make it unlimited if you want, but yeah, by default it's 3. So you can set retry disable or off. I think that is the option, or just set a different number.
So the retry is like exponential backup, or?
Yeah, it's not. Yeah, it's an exponential, but has some special jitter, so they won't retry at the same time. Yeah, it will be a random value, but it will be incremental based on a factor. So if you have 10 chunks that needs to be retried, they won't be retried at the same time. Otherwise, you can saturate the, the endpoints. Yep. Is the question if the input Prometheus scraper has dynamic configuration? Oh, no. Right now the config is pretty static, so you just tell the endpoint, yeah, and that's it. Yeah, there's some requirements about that. It's like, what? Yeah, because Prometheus endpoint sometimes you are scaling up, you have more, how do you do service discovery, to all this stuff. I think that for inside Kubernetes that is solved, you should use Prometheus with service discovery, right? But outside of Kubernetes, yeah, we need to fix that. Okay, if there's no more questions, we'll leave it here. Thanks so much for coming.